One of the things I enjoy doing the most is and has always been gardening. So if I like gardening, why should I pay any attention during pre-calc? And how can any of this help me? Let's say that you have a garden that is 1,020 square feet, and you want to fill it with plants. The plants you bought double in number every 3 days, and each plant takes up 1.5 feet squared. How long will it take for the garden to be full? The first thing we have to do for this problem is find out how many plants will fill the plot. This is because using the doubling formula, which is final value, or A of t, equals initial value times 2 to the t divided by p power. We are trying to find the time, or t. We can divide the 1,020 feet squared of the plot by the 1.5 feet squared of the plant, and figure out that 680 will be the final number of plants that can fit into the plot. The next step is to plug in what you know. Our final value is 680, our initial value is 1 plant, so we use the 2 in parentheses because it's a doubling problem, and p, or our parameters, is 3 because that's how many days it takes to double 1 time. And that will leave our equation looking something like this. For our third step, we take the equation and put each side of it into the y equals section of the calculator, substituting x for t, and where the 2 lines intersect is our answer. Our graph will look something like this. So, using the doubling formula, we can find out that our garden will be full in 20. For another example, let's say that bugs have infested your plants. Pesticide A will kill 30% of the bugs and can be sprayed every 7 days. Pesticide B will kill 37% of the bugs every 10 days. If you start with 560 bugs, which pesticide will be most effective after 100 days? This is an example of an exponential decay function, which we calculate using p of t equals initial value times 1 minus the rate of decay to the t power. In this case, we're trying to find p of t, or the final value, so our first step is to find t, or time. Our time period is 100 days, but the pesticides decay at different rates, so we need to convert them into the same time unit. 100, our total time, divided by 7 gives us 14.2857 units. For pesticide B, we do the same and we get 10 units of time. Then we plug in what we know. We're going to end up with 2 equations here, but for both, the final value is our variable. The initial value is 560, and the rate will be either 30%, meaning 0.3, or 37%, meaning 0.37. And the time will either be 14.2857 or 10. We end up with 2 equations to solve that look like this. Using basic PEMDAS and algebra, we come up with pesticide A leaving us with 3.4279 bugs at the end of 100 days. Pesticide B leaves us with 5.5159 bugs, which is a vast difference. Clearly, pesticide A wins. That's all. I hope you enjoyed the video and have a nice day.